So we have talked about inverses when it comes to a table, and then we discussed domain and range and really focused on tables of functions and their inverses. Then we moved on to graphs and how to look at a graph and tell if that function has an inverse that's also a function. Now we're going to move to the algebraic representation and look at how to find inverses algebraically. And just a reminder that the notation f with that -1 that looks like an exponent is not actually an exponent. It's how we notate that function is the inverse of f of x. And then g inverse of x would be like that. And it's important to note that this does not mean the same thing as a negative exponent, where with negative exponents we would just put that into the denominator. It's not a negative exponent. It is to note that this is the inverse function. So to find the inverse algebraically, the first thing we do is f of x, g of x, h of x, whatever our function notation is, we replace that with y. Then we switch the variables x and y, because remember, the very first thing we learned about inverses is that we switch the x and y values. So once we switch the variables x and y, we then solve for our new y, which means get y by itself. So once we swap where x and y are, we then get y by itself. And once we do that, we write using the inverse notation, the inverse f inverse of x. So in our examples here, if you look at letter A, well, we don't have f of x. It just says y. So step 1 has already been done for us. So since step 1 has been done for us, we're going to switch where x and y are. Notice that only the letters switch, not the numbers. So that 7 that was in front of the x is still there, and we just switch where x and y are. So now it's x equals 7y minus 4. Okay, then we get y by itself. So we have x plus 4 equals 7, 7y. And then we divide both sides by 7. And then that will be x plus 4 over 7 equals y. Y is now by itself, so we can write that in inverse notation. The inverse of y is equal to x plus 4 over 7. You might say, well, why didn't you use f of x? I didn't use f of x because the original was y. So then the inverse of y would be x plus 4 divided by 7. So that would be, like I said, our final answer. Now in letter B, we have f of x equals negative 5x plus 2, so y equals negative 5x plus 2. Then we're going to switch where x and y are. And now we need to get y by itself, so we'll subtract 2 from both sides. X minus 2 equals negative 5y. Divide both sides by negative 5. So that gives us x minus 2 over negative 5 equals y. Y is now by itself, so that means our inverse. And we originally started with f of x, so it's going to be the f inverse of x is equal to x minus 2 over negative 5. Letter C, we have a fraction to deal with. So y equals 2/3 x minus 5. So we're going to switch x and y. Then we need to get y by itself, so we'll add 5 to both sides. So x plus 5 equals 2/3 y. Now to get rid of that 2/3, we have to multiply both sides by the reciprocal, so 3/2, because that will get rid of the 2/3 in front. So this 3 needs to be distributed to both things. So it's going to be 3x plus 15 over 2 equals y. So we're going to be doing a lot of algebra here in our inverse operations, adding stuff to both sides, multiplying stuff on both sides. So our algebra skills really need to be in tip-top shape. So y is by itself. So now we have the inverse of f of x is 3x plus 15 over 2. All right, so I want you to try letters D and E, pause the video, try them, and once you're done, unpause it, and you can see if your answer matches mine. All right, so in these two problems, I want to note something. Letter D, the inverse was the exact same as the original function. That's okay. That is allowed to happen. Our original function was negative x plus 7, and then when you calculated the inverse, right here, when we divided both sides by -1 to make it positive y equals something, x divided by -1 gives us negative x, and -7 divided by -1 gives us positive 7. So yeah, the original function and the inverse function are exactly the same. Then letter E, at this point right here, you should have been able to get that far because of a letter C. Well, that divided by 3 goes to both things. So when we have 36 divided by 3, that equals 12. But -4 is not divisible by 3, so that's why it stays in the fraction. So that would be your inverse. If you got to the yellow highlighted part, I'm happy right now. We just need to make sure we're simplifying our algebraic expressions. All right, now on the next page, word problems. The only difference with word problems is that we don't switch the variables, because in word problems, the variables mean, like they represent a real situation. So if we switch the variables, now we switch the meaning of the problem. So instead, what we do is we just solve for the other variable. So we get the other variable by itself. So a small greeting card, a small company produces greeting cards. The cost, C in dollars, of producing n greeting cards per month can be modeled by that function. C equals 360 plus 0.6n. So C equals 360 plus 0.60n. So the inverse model, instead of switching where the variables are, we're going to do algebra to get n by itself. So we're going to subtract 360 from both sides. So C minus 360 equals 0.60n. And then we divide both sides by 0.60. Now we don't need those extra zeros. So C minus 360 divided by 0.6 is equal to n. So now we've calculated the inverse by getting the other variable by itself. What that allows us to do is to answer questions like letter B, where it says use the inverse function to find the number of greeting cards produced in a month in which the company total cost was $615. See, normally, if the cost is $615, we would plug that in for C and get n. Try to get n by itself to figure out the number of cards. But in our inverse function, let me rewrite that over here. Our inverse function is n equals C minus 360 divided by 0.6. We're going to plug in 615 for C, and then it's just one calculation. So we did all that solving first. So 615 minus 360 all over 0.6. So then in the calculator, we're going to do 615 minus 360, hit enter, and then divide by 0.6, and we get 425. So n equals 425 cards. Right, now the last thing we're going to do is talk about how we can tell if two functions are inverses of each other. There are two ways to do it. What I think is a more complicated way is that if we do the composition, remember the composition is when you take one function and plug it into the other. So if we do the composition both ways, meaning we take f and plug it into g, and g and plug it into f, if they both equal x, then they are inverses of each other. So if f of g of x equals x, and g of f of x equals x, then they're inverses of each other. Now, I think that is a lot of work, especially when we're dealing with fractions and stuff like that. So what I want to do instead is let's just calculate the inverse of f and see if we get g. So y equals 3x plus 2. Switch our x and y. Okay, so then we're going to subtract 2 from both sides. So we have x minus 2 equals 3y. And then we divide both sides by 3. And we can't simplify any of these fractions. We have x minus 2 divided by 3 equals y. So the inverse of f of x is x minus 2 divided by 3, which is not the same as g of x. So not the same as g of x. So f of x and g of x are not inverses. That was a lot faster than trying to calculate both compositions. So I would think it's easier to do it that way, but if you want to do both compositions, I'm not going to tell you no. So that's it for calculating inverses algebraically. Thanks for watching. Make sure to like the video and subscribe.